Hi, my name is Nida Atif, and my study is on the influence of divorce rates by twin birth rate. So twins have often been discussed upon because of how unique they are, but we also know that with twins comes a lot of burden and increased financial stress. So there is that downside of it, and that may influence a couple and their marriage, which is a topic, and which may lead them to unfortunately get a divorce. So that is the whole concept of this report, is to prove, of the studies, to prove the correlation between the two variables. I found a report by the Twin and Multiple Births Association, and they found that 62% of birth families said that they're financially worse, and they found that 28% of parents of twins and triplets separated after divorce. So this kind of supports what I'm trying to prove, that there is a correlation, so one does affect the other. The focus question of this study is, does natural twin birth rate influence the divorce rate? And the hypothesis is that yes, indeed, natural twin birth rate does influence the divorce rate. This study is meant to outline and provide all the knowledge needed to understand the correlation between the two variables. And I personally chose this study because I myself am a twin, and there are times where I feel with my twin that we feel that we are a very big burden on our family, but we can't do anything about it. So it's just something that I connect to in a way, and I wanted to further look into it. So my two variables are the natural twin birth rate, which is the independent variable, and my second variable is the divorce rate, which is the dependent variable. Both of my variables are discrete because you cannot have half a divorce or half a human or half a pair of twin, so I only have discrete variables. So for my first variable, I have a histogram showing the central tendencies, which is the mean, and I have two standard deviations. Basically, the standard deviation closest to the mean shows us that the data is closer to the mean, but the standard deviation away from the mean, it shows that the data is more dispersed. As you can see, there's a cluster, a lot of it right there, and then it gets like dispersed over, which causes this standard deviation. Looking at this graph, it's also positively skewed. So the natural twin birth rate is positive. And this is a box and whiskers showing the exact same thing except in a different type of spread. Shows the mean, shows the minimum and the maximum, and then the three quartiles where most of the information is placed. So the interquartile range is basically a way to calculate where 50% of the values are, and my interquartile range was 38, so anything below negative 19 is considered an outlier, and anything below above 95 is considered an outlier. For my z-score, I just picked a random number, put in the mean, put in the standard deviation for sampling, and I got that 35.2% of the data will be greater than 15. I know this makes sense because this data is below 15 and there's majority of it, so if 35.2 is here, then the rest of the data is below 15, so that makes sense. My second variable is the same thing, positively skewed. I made a histogram for it, 3 standard deviations above, 2 below. The mean again describes how this is closer to the mean, so that's why there's a lot of points here. And then the further away you get from the mean, the less data there is. Well, there isn't less data, but it's more dispersed over, it's more dispersed. Same goes for the box and whiskers. Minimum, maximum, 3 quartiles shows us where most of the data is displaced. So it would be between 1 to 2. So that's why it's fairly, this quartile is still bigger than this one, but it's fairly, similar. Again, for z-score, random number, then put the mean in, the standard deviation for sampling, gave me the probability that 85.99% will be less than 3. And I know this makes sense because this is less than 3. So 85.99% of the data is less than 3, which is majority of the data points, and it makes sense. You can physically see that this would be above would be lower, and then below would be 85.99%. Okay, so for my linear regression, interpolation, extrapolation, so for my two variable analysis, I have the divorce rates going up here, the natural twin birth rate going down here. So this graph is with outliers, and as you can see that there's an outlier here and then there's an outlier here. So this is the highest point. I think this is like 6 something, or I don't know right now, but it is in the Excel what the outliers are, and this one as well. So when I was making the graph, it gave me the R squared. To find the R, I basically square rooted it, and the R value is 0.4150, and basically R is a correlation coefficient, so that is what determines how the R value is the correlation, is the value of the correlation between the two variables. So just by looking at, like, even if we didn't know the R squared or the R value, just by looking at it, seeing the line of best fit positive, we would be able to tell that, oh yeah, you know, these two variables have some type of like interrelation. So 0.4150 is a moderately positive correlation between the two variables. And extrapolation is basically estimating the value based on expanding a known sequence of values, and interpolation is finding values within a gap. So how I looked at it was, if I wanted to find a value here, I have data on this side and I have data on this side to help me determine the value that I want, which is in here. That was for interpolation. And then this one is linear regression without outliers. So we can see that the scale only goes up to 3.5 here and then 25 here. And then for the one with outliers, it was going up to 7 and 30, because they kind of, like, they pull the line of best fit, so the data points have to be placed. But without, we can see that the slope changed, and the y-intercept changed, and the R squared changed as well, which means that now, after the R squared is rooted, the new one, the correlation coefficient is, where is the correlation coefficient? Is 60.70. So although it is between the same scale, so on the scale we have 0.33 and 0.67. So with the outliers, it was 0.4150, which is still moderately positive correlation. And after taking out the outliers, we could see that our line of best fit is better in a way, because the graph without the outliers is more trusted than the one with the outliers. So even though our R value changed, it's still a moderately positive correlation between the two variables. So one cause and effect relationship I chose between the independent-dependent variable would be the cause and effect, because we can see that through this data, we can see that as the divorce rates go up, the twin birth rates, as the twin birth rates go up, the divorce rates go up as well. So the X influences the Y. So that's why I chose a cause and effect relationship to measure to determine the correlation between the two. X influences the Y, which gives us the moderately positive correlation between the two variables. So the conclusion of this study is that looking at the graphs, the independent variables, the histograms, and then putting them together in the linear regression, we can see that the two variables do have a very strong, but there is some type of connection between the two, which is moderately positive correlation. So the natural twin birth rates is independent and the other one is dependent. And I gave an example of how one point had a very high twin birth rate and the same point had a very high divorce rate as well, to support the purpose of the study. And a few limitations of the correlation were the undocumented natural twin natural twin birth rate and the divorce studies because both of them were in third world countries. So the links that I have, if you click on them, you can see that they're mostly in third world countries. So just the documentation process of that would be a bit unreliable because they are missing the unidentified numbers. One hidden variable would be, for both variables, would be financial stability. Because the the one hidden variable, which can also be common cause, because one variable influences both, would be financial stability. Because the financial stability of a family allows a couple to keep their twins, or end up like giving them to an orphanage or whatever. So just the financial stability, influences a couple, and the same financial stability influences divorce as well, because if one partner is very rich, the other would want to split it through the will. Then we also have the outliers, which are present by due to religious belief, society, and documentation process. So maybe due to religious beliefs, the divorce rate is very low because divorce is frowned upon, yet the twin birther would be really high, so that would be an outlier. And this study has measurement bias because again, for the data for both variables does not represent the entire population, where a lot of the documentation may have been missing. So there may be points that were never documented, thus making it a measurement bias. And throughout the whole study, the final result shows that there is a moderate correlation between the two. And a recommendation for future studies would be to research more on the extraneous variables, because they do have some of the hidden data that has been documented, which does in a way make the data given a bit false, because there is no other data to prove to add on to it. But yeah. And this is my works cited, and at the bottom there's just the calculations that I extracted from Excel and put them in charts for me to better read it and understand it, and you will get the Excel as well. Thank you for listening.